Hey, this is lesson 1 from chapter 7. We are developing linear systems today. So this is just an introductory lesson. It's a little bit shorter than the other ones in this chapter, but it's just getting us used to the idea of what a linear system is and how to set one up before we start really diving into how we solve these things. So first, I'll just tell you what a linear system is. It's just when you have more than one linear equation. So it's just a set of linear equations. We've seen lots of examples of linear equations in this course. We did a whole unit on them just last unit. So we're going to be dealing with not one, but two linear equations in this unit together and figuring out how do we solve those things. Okay, so I have 3 word problems for us to go through. We're going to practice setting up these linear systems. Okay, in each of these problems we're going to have 2 linear equations. So for a linear system. Okay, so first one here, and I'm just going to use my highlighter as I read. It says Ben is 2 years older than Angela. That's clue number 1. And clue number 2 is the sum of Ben and Angela's ages is 34. So what you'll find in this chapter is typically we're going to be having 2 equations. So when it's a word problem, usually they're going to give you like 2 clues, I call them. So in this 2 pieces of information. So I have my yellow piece of information, which is Ben is 2 years older than Angela, and my pink piece of information there, which is the sum of their ages is 34. Okay, the question says, create a linear system to model the situation. Let's start there. Okay, so first thing we want to do when we're writing equations, we don't really want to write Ben and Angela's name over and over again because it just takes a long time. So we want to come up with a letter or a symbol to represent their ages. So because they start with different letters, let's just use B for Ben. Oops, I forgot to write the letter B. Let's use B for Ben's age. And let's use the letter A for Angela's age. And you don't have to make them lowercase. It doesn't matter. You don't even have to make them A and B. You could make them X and Y. It just, as long as you tell the reader what you've made your letters, you have to, so this is called defining your variables. You have to do that. Your variables. Because otherwise the person might read the question and be like, hey, what do these letters actually mean in reference to the problem? Okay, so let's do the yellow clue first. We're going to have an equation to represent that yellow sentence there. So it says Ben is, now what I usually tell my students is this word is in math, whenever we're trying to translate something into an equation, is typically going to be where our equal sign is. So Ben is, so B equals 2 years older, so 2 years above or 2 years added on to Angela's age. So there's our equation. Let's write it down. Ben is 2 years older than Angela. There we go. That's our first linear equation. Let's do the pink one. So the sum of Ben and Angela's ages is, here's my equal sign again, 34. This word sum means add together. So Ben and Angela's ages together equals 34. So here's my equation. B plus A equals 34. Now the other part of this question says, can you solve it? So these equations are fairly straightforward. So you might just want to like guess and check to solve here. We're going to come up with much more sophisticated ways to solve these linear systems, but because these are pretty simple clues, we can just guess and check. So like, let's try things that add to 34. So we could try like 20 plus 14. Yeah, that equals 34, but it doesn't satisfy the yellow equation. So no, that wouldn't work. Maybe let's try 18 plus 16. What if Ben was 18 and Angela was 16? Yeah, those add to 34, and 18 is equal to 2 plus 16. Yeah, so that would work. So Ben is 18 years old and Angela is 16 years old. Right, so that works. So we just guessed. But we are going to find much better ways to solve equations like this rather than just guessing and checking. But for now, that's kind of our only method here. Okay, let's try another example. This one has to do with areas. So just like before, we're going to have two clues. I'll label them with colors again. So our first clue is that the total area of both lots is 225. The second equation is the larger area is twice as big as the smaller area. Create a linear system to model. Okay, let's just let's pick some letters here. I don't typically like to use S and L because S looks really like a 5. So I kind of avoid using the letter S for a variable. So here, because I'm tempted to use S, maybe I'll just use X. So X will be my small area. I'll even put it in the box here. And Y will be my large area. Okay, but you could use any letters you want. Just X and Y are kind of like typical things that we might use. Okay, let's write down an equation for the yellow one. So usually, again, where this is usually where the equal sign is in the equation when we're trying to write this down. So the total area of both lots is 225. Total is another way of saying when you add them together. So if I add X plus Y together, I'm going to get 225. That's my first equation. Let's write it down. X plus Y equals 225. Okay, now for the pink equation, the larger area is, there's my is again, that's where my equals sign goes. The larger area is, so Y equals twice, so 2 times as big as the smaller area. So 2 times X. Twice as big as means double, or 2 times. So the equation would be Y equals 2X. So there's my 2 equations. And part B says verify that 75 meters squared, which would be the X, and 150, which would be the Y, is a solution to the system. So when we verify, what we do is we plug the answer in to see if the equations make sense. Kind of ran out of room there on the makes sense, but that's okay. There we go. Okay, so let's do equation 1, the yellow equation. So where the X is, I'm going to put 75. And where the Y is in the equation, I'm going to put 150. And those are supposed to add up to 225. Let's see if they do. If I add 75 and 150, yeah, it does equal 225. So that equation makes sense. The 2 areas do add to 225 meters squared. Okay, let's try equation 2, the pink equation. I'm going to put, where the Y is, I'm going to put 150. And where the X is, I'm going to put 75, since that's what we think the answers are. Okay, so let's see if that makes sense. 150 is equal to 2 times 75. Yeah, that's 150 also. So yeah, that makes sense. So 75 meters squared, 150 meters squared is a solution for both equations. So we say it's a solution of the system. Those 2 areas work out. Okay, let's do the last one. It's the hardest one. This is going to be one that you'll see throughout the chapter. So I did want to put it here because you'll see it definitely a few times and maybe even on one of our quizzes or tests. Okay, so first piece of information is you invest $6,000 into 2 different accounts. Okay, and then it says in the first year, the first account earns 5% interest. And the second account earns 7% interest for a total of $340 altogether. Write a linear system. So we have 2 accounts here. The default letters I always go to are just X and Y. So X is going to be the amount in account number 1. And Y is going to be the amount in, if you use those little symbols there, it just means the same. So amount in account number 2. And let's do our yellow equation here. So there's no is word in this, but the total amount that I'm investing here is $6,000. So the amount in account number 1 plus the amount in account number 2 has to add to $6,000. So X plus Y is going to be $6,000. You can leave units out of your equations. Okay. And then our pink equation here. Okay, when I do interest, when I calculate an amount with a percent, I have to change it to a decimal. So if you forgot how to change a percent to a decimal, you just divide it by 100, or you move the decimal place over to the left twice. So it would be 0.05 times the amount in account number 1. That would give me my interest earned in account number 1. And then 7% would be 0.07 times the amount in account number 2. And all together, it's going to be $340. So there's my two equations. It doesn't ask us to solve this here, so we're just going to leave it like that for now. But I wanted to show you this example because it is going to pop up a few times with percentages in this chapter. Okay, that's it for lesson 1.